So what is enthalpy change of formation? It is the energy that is released or absorbed when 1 mole of a substance is formed from its constituent elements in the standard state measured under standard conditions. So whenever you see something like this, enthalpy of formation of ethanol, that means 1 mole of ethanol is being formed from its constituent elements. So it's the energy change for this particular reaction. Enthalpy of formation of carbon dioxide, it is 1 mole of carbon dioxide being formed from its constituent elements. So it's the energy change of this particular reaction. And I told you that enthalpy in the last class, I told you that enthalpy of formation of elements is always considered to be 0. Then we did enthalpy change of combustion. In enthalpy change of combustion, it's the energy that is released when 1 mole of a substance burns in excess oxygen measured under standard conditions with everything in the standard state. And we talk about burning it in excess oxygen. So that means complete combustion. We're talking about complete combustion. And the other thing is, just a second. And the other thing is the enthalpy of combustion of elements that have already combusted, that is 0. So this is something that we did last time. We also did enthalpy change of atomization, where you make 1 mole of atoms, gaseous atoms, from its element in its standard state. So if you want to make chlorine atoms, you have to break the chlorine bonds in the chlorine molecules and make 1 mole of chlorine atoms. If you want to make carbon gaseous atoms, you would have to break the carbon bonds in the element that is carbon, which is usually graphite or diamond. If you want to make oxygen atoms, you're going to break the oxygen bonds in the O2 molecule. So this is always endothermic. It always has positive value. Let's move to the next definition, which is standard enthalpy change of neutralization. So let's talk about that now. So this one is known as standard enthalpy change of neutralization. Standard enthalpy change of neutralization. इसमें क्या होता है? What happens is this is known as delta H N with a knot on top. That is enthalpy change of neutralization. What happens in this is that it's pretty obvious that it's an acid-base reaction. It's the energy that would be released when 1 mole of water is produced. When an acid and an alkali react. Or simply base react. So when an acid and a base react, measured under standard conditions. So the two things to this. One is that 1 mole of water is going to be produced in the reaction. And when would it be produced? When an acid and a base, they react. And it's always going to be exothermic. Neutralization reactions are always exothermic. So one thing is that it's always exothermic. always negative. So it's always negative. And so what is any acid base reacting? So we can make an equation. I've got NaOH reacting with HCl and it's producing NaCl and water. So it's NaCl plus H2O. So as long as you're getting 1 mole of water, this enthalpy change of this particular reaction, as long as you're getting 1 mole of water, the enthalpy change would always be known as the enthalpy change of neutralization. So if you have another reaction, and in that reaction, like if you have KOH reacting with H2SO4, and instead, like if you balance this, it's going to be K2SO4 plus, and if you balance it, you're forming 2 moles of water. So this is not the enthalpy change of neutralization because that is for 1 mole of water. So this is basically the enthalpy change of neutralization, but twice the enthalpy change of neutralization because you're forming double the amount of water. Ye clear is our Ahmed, Sidra, is this clear? Oswa, is this clear? Hania?
Yes.
Yes.
So enthalpy neutralization, 1 mole of water is produced from its constituent, acid and base, right? And they're going to react. Now, the thing is, we're going to discuss 2 things. First one is, why is it exothermic? That's one. And another thing is that it usually always has the same value. So delta HN is equal to minus 57 kilojoules per mole. It's equal to minus 57 kilojoules per mole for any strong acid or base. So no matter what the reaction is, it's always the same. It's always the same value. So the question is, so why is it always the same value? And the answer to that is basically the reaction that's happening is that the acid produces H plus 1 ions. It produces H plus 1, and you've got a base, and that produces OH ions. So it's a reaction of H plus 1 with OH ions. And they end up forming H2O. The rest are all spectator ions. That's it. I mean, they're not really doing anything. So the rest are all spectator ions. So what that means is, so the rest are all spectator ions. So what that means is that every time you have the exact same reaction, you always have exact same reaction. Because whether it's HCl or whether it's H2SO4 or whether it's HNO3, the acid simply produces H plus 1 ions. And we don't care what the base is, whether it's NaOH, KOH, BOH2. The role of the base is to produce OH ions. And the overall reaction that happens, or the ionic reaction that happens, is that H plus 1, they combine with OH ions to form H2O, and that's about it. And there's
सर स्पेक्टर आयंस क्या होते हैं?
वो ये होते हैं कि एक कर लेते हैं कि I've got a reaction है HCl plus NaOH, and they're reacting together to form NaCl plus H2O. ठीक है, अब ये याद रखना कि whenever something is aqueous, HCl aqueous है, or NaOH भी aqueous है, और NaCl is also, और H2O जो है ना वो liquid है. अच्छा, spectator ions ये होते हैं which don't do anything in the reaction. For example, HCl is aqueous. HCl aqueous का मतलब है कि solution के अंदर ना, let's say container है, उसके अंदर दोनों को बीच में डाल दिया आपने. This has been added and this has also been added, और ये solution है. अच्छा, HCl aqueous का मतलब है कि H+1 जब आपने चम्मच से उसको हिलाया ना, तो the H+1 and the Cl-1 have dissociated. NaOH के बिना Na+1 और OH-1 ना वो सारे अलग अलग हो गए, और they're surrounded by water molecules, these tiny water molecules. वो उनको उन्होंने अलग रखा हुआ है. कोई भी कंपाउंड होता है, some compounds they ionize in water, ठीक है, और ionic lattices already ionized होते हैं. This is like if I show you ionic compound dissolving. So this is what happens when an ionic compound dissolves. कि शुरू में ना they are forming, ये बल्कि कौन सा ज्यादा अच्छा है, एक सेकेंड. So this is, ये देख लेते हैं एक सेकेंड. डिसोसिएट होने का ये मतलब है कि जब आप सॉल्ट लेते हो ना, Na+1 पॉजिटिव नेगेटिव आयंस आर ऑल अट्रैक्टिंग ईच अदर एंड दे फॉर्म दिस क्रिस्टलाइन सॉलिड. जब आप उसको चम्मच से विगरसली हिलाते हो ना पानी के अंदर, व्हाट हैपेंस इज वो ऑल दोस आयंस दे स्टार्ट डिसोसिएटिंग. Na+1 अलग हो जाता है, Cl-1 अलग हो जाता है, दे गेट सराउंडेड बाय वाटर मॉलिक्यूल्स. ठीक है, तो हर जगह यही होता है. जब भी आप क्रिस्टल को ना, आयोनिक लैटिस को, पॉजिटिव नेगेटिव आयंस ऑल अट्रैक्टिंग ईच अदर, जोर जोर से चम्मच से हिलाते हो पानी के अंदर, द आयंस दे ऑल गेट स्कैटर्ड. ठीक है, ये बात क्लियर है?
Yes.
अच्छा, so the thing is कि जिस चीज को हम, the thing that we call HCl, it's not actually HCl. क्योंकि जब आपने उसको चम्मच से हिलाया था ना पानी में, what happened is that the H+1 and the Cl-1, they're now, वो सारे अलग अलग, they're all traveling randomly, haphazardly in different directions. ठीक है, सारे के सारे पानी के अंदर कंप्लीटली मिक्स हो गए. ठीक है, तो ढेर सारा पानी का मॉलिक्यूल, पानी है. अच्छा, सो ढेर सारा पानी है और H+1 वो सारे फ्लोट अराउंड कर रहे हैं, they've completely gotten scattered. ठीक है, अच्छा, अब इसमें ये याद रखना है कि ये वाटर मॉलिक्यूल बहुत ज्यादा है. ठीक है, there are lots of water molecules, so the ions are not able to get together. अच्छा, anyways, when you mix them, so what happens in the products? What are the products that are forming? The products that are forming are, if I make this container again, so what happens is कि ये जो H+1 है और जो OH-1 है, these two get together and they form water molecules, जो कि पहले ही थे लेकिन अब और ज्यादा हो गए. So they ended up forming water molecules. अच्छा, this OH ion and this H+1, they got together as well and they ended up forming water molecules as well. और NaCl soluble है तो उसके आयन स्कैटर्ड ही रहते हैं, वो it's still aqueous. So इन दोनों में डिफरेंस देखो. What is Na+1 doing? It's doing absolutely nothing. कि Na+1 पहले भी वैसे ही था और बाद में भी Na+1 exactly वैसे ही है.
तो सर इन्हें NaCl क्यों कहते हैं? फिर Na और Cl अलग अलग कहना चाहिए, लाइक Na+Cl.
नहीं, NaCl aqueous का मतलब ही वही होता है.
अच्छा,
कि साथ अगर aqueous, अगर वो सॉलिड है ना, फिर वो सॉलिड है तो फिर वो सारे जुड़े हुए हैं. अगर वो NaCl in water होगा तो वो they all scattered. ठीक है, अच्छा, so the point I'm trying to make is कि acid base reaction में ना, the Na has nothing to do. It's not even taking part in the reaction. It's absolutely doing nothing. Similarly, the Cl-1 is not doing anything. Okay? The only thing is that the acid provides H+1 ions. मतलब इसकी तरफ से ना H+1 ions आते हैं और इसकी तरफ से you get OH ions. So you got H+1 from one of them and OH ions from the other one, and the two combine to form H2O. The Na+1 is not doing anything. That's a spectator ion. The Cl-1 is not doing anything. That's a spectator ion. So instead of NaOH, if it had been KOH, if it had been any other positive ion, the reaction would have been exactly the same, and exactly the same number of bonds would have been formed, which is why the enthalpy change is always going to have the same value. Clear hai baat? Is this clear to everyone?
Yes.
Yes.
So, so they have exactly the same value. Now another issue is, and that other issue is, sometimes you have weak acids and weak bases. So what happens to the enthalpy change of neutralization? Just a second. One second. So what happens to the enthalpy change of neutralization if you have a weak acid and a weak base? So weak acids, weak bases have slightly less exothermic delta HN. Slightly less exothermic. That means the delta HN would be around minus 53 kilojoules. It would be minus 52 bhi ho sakti hai. So minus 52 or minus 55 kilojoules per mole, not minus 57. Achha, why is it less exothermic? It's less exothermic because what is a weak acid? A weak acid doesn't like to ionize. It doesn't ionize easily. So weak acids don't ionize, or weak acids partially ionize. Achha, partially ionize. Iska matlab hai ki let's say you have an organic acid that's a weak acid like ethanoic acid. इसको आप पानी में mix करोगे. अब पहले वाले केस में they would easily mix and dissociate in water, like HCl would very easily mix and ionize in water. आप चम्मच से लाते थे, the H+1 and Cl-1 ions would dissociate and would split up. But now you have a weak acid. A weak acid does not like to dissociate. तो आपको क्या करना पड़ेगा? थोड़ी सी चम्मच ज्यादा जोर से हिलानी पड़ेगी. You'll have to mix it harder. ठीक है, you would have to give it energy क्योंकि it's not breaking down. कि you put it in water, the H+1 ions are not going to be produced. So for example, you put it in water and you stir it, it will not dissociate. That means some energy is needed. You want the H+1 ions to be produced क्योंकि तभी reaction होगा. So you want this beaker. Acha, this one. So some energy is needed to ionize it. And दूसरी side पे you have a base like NaOH. That is a strong base, it will ionize. So the problem is the reaction is between H+1 and OH-1. You want them to react with each other, but they can only react if it ionizes. If it's not even ionizing, there would be no reaction. So that means weak acids partially ionize, and some energy is needed to ionize the weak acid or base. You was clear? You get the point? Is this clear? Yes or no?
Yes.
So can you explain this
इतनी
again?
सही से समझ नहीं आई जी.
अच्छा, उसमें ये कि पहले क्या था, like HCl you added it to water, चम्मच चलाई, you stirred it with a spoon, and all the ions dissociated and they got scattered. And then the H+1 ions from the acid and the OH ions got together and they reacted together to form H2O. Okay, clear? So the reaction was very easy. You do clear, na? Ahmed, is this clear? Okay. But what if you have a weak acid? Now the problem with a weak acid is कि you add it to water, you stir it, it doesn't ionize. मतलब उसका जो H+1 है ना, I mean this H+1, वो अलग ही नहीं होता. वो it's still attached to this thing. So the reaction cannot happen. Why? Because the H+1 is still stuck with this thing. क्योंकि reaction क्या था? The H+1 and the OH ions must meet together to form water, right? That is what an acid-base reaction is. ये बात clear है?
जी.
ठीक है. तो how do you ionize this? You heat it up. मतलब ताकि molecules की आपस में they have more collisions. If they have more collisions, then there are chances कि H+1 dissociates and breaks away. So this is why some energy is needed to ionize weak acids or bases. Is this clear?
Yes.
लेकिन सर इसका एक्सोथर्मिक होने से क्या रिलेशन है?
क्योंकि अब थोड़ा सा एंडोथर्मिक हो गया because some energy is needed, right?
ठीक है.
तो इसका मतलब है your value is now less exothermic because बीच में ना you have to give it, so it becomes less exothermic or it kind of becomes more endothermic. ठीक है, तो इसलिए वो value change हो जाती है because बीच में you would have to give it energy so that you would have to heat it up because वो H+1 अलग ही नहीं हो रहा, so you have to kind of heat it up, give it energy so that the H+1 breaks away. So some energy is needed to ionize weak acids and bases, which makes the overall reaction less exothermic. It makes it less exothermic. ठीक है? So the thing is that so which makes the overall reaction less exothermic. So just remember the main point is the value is always going to be minus 57 for strong acids and strong bases because they ionize on their own. You don't have to put in a lot of effort. But when it comes to weak acids, the value is for weak acids and weak bases, the value is slightly less exothermic. So by just looking at the value, you should know that whether it's a strong acid or weak acid. So what are weak acids, by the way? Okay, that's another question. Which acids are weak acids? So I'm going to make a list of strong acids. So I'm going to make a list over here. So which ones are strong acids? As strong acids are usually your mineral acids. Or you can call it your inorganic acids, like HCl, HNO3, H2SO4. These are all your strong acids. Phosphoric acid, etc. So which ones are strong bases? So strong bases are your group 1 hydroxides, like NaOH. So they're group 2 hydroxides. Like BaOH2. Again, later on we're going to study group 2 separately. So group 1, group 2 hydroxides are very strong bases. The other ones they don't dissolve a lot. So these are the ones that are really strong bases, and not the entire group 2. The group 2 hydroxides lower down in the group. So what about weak acids and weak bases? The strong acids ho gaya. You've got your strong bases. So weak acids, identifying weak acids is very, very simple. Okay, who's your weak acid? It's your anything that has carbon in it. Organic acids, which contain carbon. For example, carboxylic acids. Etc. And which ones are weak bases? Weak bases are the ones that have nitrogen in them. So these are nitrogen bases like ammonia, that's a weak base. Like amines in organic chemistry, that's a weak base. So you should have an idea of which ones are strong acids, which ones are weak acids. Organic acids are weak. Organic bases are weak, like nitrogen bases. Which ones are strong bases? Group 1 hydroxides, group 2 hydroxides, the ones that are lower down in group 2. Strong acids, HCl, HNO3, okay? So you should know which ones. So the difference between the value is just going to be very slight, but there are a lot of questions on this. Minus 57 indicates a strong base or strong acid. Anything less than that, less than this value would mean that it's a weak acid, weak base. Okay, is this clear? Is that clear, Sarko?
Yes.
Yes.
So, and then there is, so that's about it. Okay, and remember, every time, why is the reaction the same? Because every time it's the same exact equation. The acid produces H+1, the base produces OH ions, and you get the same reaction. So it's the same reaction every time, no matter what the acid is, what the base is. So the value kind of is always similar. So that is enthalpy change of neutralization. Okay. Just 1 second. Let me also go through the latest 971 syllabus. Because this year the syllabus has changed, so we should always keep a syllabus with you, because even the books that you read from, they're older versions now. Just 1 second. No, this is for 2021. Where's the latest one?
Sir,
हाँ जी.
so ये calculation से last chapter था ना, ये भी है?
नहीं, calculation का तो और भी है.
अच्छा, okay. अभी सर moles हो गया. कौन chapters होंगे क्या नहीं?
Moles हो गए. We're doing energetics. सिर्फ moles किया है. Energetics we started. ठीक है. अच्छा, so किधर गया? Let's always keep this with us because it's a new syllabus. So for 2022, just a second. So we're done with the so which ones are left? We're done with the standard conditions. We understand standard conditions. Combustion, neutralization, and bond breaking. And that's it. A lot of things have actually been shifted to Hess law, etc. That's fine. So we're done with enthalpy of neutralization. The only thing that is left is let's do the enthalpy change of reaction. Okay, let's try and do that. And let me just quickly go through this. Bond energies, we're done with bond energies. We did all of that. So we're done with that. So only Hess law is left and MC delta T is left. So just 1 second. So let's do the last one, which is standard enthalpy change of reaction. अच्छा एक मैं चीज देख लूं यहाँ पे A2 कहाँ पे अच्छा solution and hydration ठीक है, that's all in A2 now. पहले definitions की S में थी, so we're not going to do that. And lattice energy, etc., hydration, that's all there now. Lattice energy ठीक है, वो सारा वहाँ पे. ठीक है. अच्छा, enthalpy change of reaction. Let's quickly do this and finish the definitions. Enthalpy change of reaction is, this is the most general use the word enthalpy change. Okay, so I'm just going to write this down. Most general definition of enthalpy change. Can be used for any reaction. For any reaction. So enthalpy change of reaction is that it's the energy released or absorbed. Remember, you can apply this. You can call any enthalpy change the enthalpy change, standard enthalpy change of reaction. Okay, let me write that down. This is standard. Enthalpy change of reaction. What happens in standard enthalpy change of reaction is that it could be endo, it could be exo. So it's the energy released or absorbed when it's energy released or absorbed when equation moles of reactants react and equation moles of products are produced. And this is measured under standard conditions. Now, the thing is, what does that mean? It means that if you're given a reaction, like if I'm given a reaction and it's it says that it's N2 reacting with 3H2 and it's producing 2NH3. Now the equation gives us the simplest whole number ratio. So if I go in the lab, the equation says that 1 N2 should react with 3 H2s, right? 1 mole of N2 should react with 3 moles of H2. So when I do a reaction, I could have taken any moles. I could have taken 200 moles of N2 and they would react with 600 moles of H2 and they would produce 200 moles of NH3. So I could have used any number of moles in my reaction in my lab and I could have performed this reaction. But that would, the enthalpy change or the energy change would not be called the enthalpy change of reaction. It would only be called the enthalpy change of reaction if that energy change corresponds to, like, I go in the lab and I exactly take 1 mole of N2 and I react it with exactly 3 moles of H2 to produce 2 moles of NH3. So it's the energy released or absorbed when the equation moles or the moles that are given in the equation of the reactants and products, they react. And the same number of moles of products are produced which are given in the equation, then that enthalpy change would be called the enthalpy change of reaction. So remember, we could have done this reaction with using any number of moles. I could have used 0.1 moles of N2 and I could have reacted with 0.3 moles of H2 and produced 0.2 moles of NH3. And there would have been some energy change, but that energy change would not be called the enthalpy change of reaction. It would only be called the enthalpy change of reaction if exactly the moles that are given in the equation are the ones that are reacting and the same number of moles are getting produced in the reaction. Is this point clear? You clear?
Sir, what do you mean the same number of moles produced over it?
देखो, what is an equation? Equation is simply a ratio, ना कि वो बताता है कि एक जो है ना वो 3 के साथ react करेगा, right?
Yes.
So, I mean, let's say you're performing this reaction in the lab, right? So, if there's 0.2 moles of N2, so how many moles of H2 would react with it? It's going to be according to the ratio 0.6 moles. And how many moles of NH3 would be produced? I think that would be 0.4 moles, right? Clear?
Yes. यानी कि lab से same values होनी चाहिए.
तो उसकी कोई एक particular enthalpy change आएगी. Let's say I call it, well, there would be some energy change for this reaction, that let's call that enthalpy change X, ठीक है? But I will not call it the enthalpy change of the reaction, delta HR, standard enthalpy change of reaction. Because standard enthalpy change of reaction, delta HR, corresponds to कि you are performing the reaction and you're using exactly 1 mole of N2 and they're reacting with exactly 3 moles of H2 and they're producing exactly 2 moles of NH3. Then the energy change would be called the enthalpy change of reaction. Is this point clear?
Okay.
So equation moles of products and equation moles of reactants. So the moles that are given in the equation.
तो सर अगर equation वाले moles for example 0.2 वगैरह होते तो फिर जो ऊपर वाला है उसका जो enthalpy of reaction आता वो फिर ना होता सही, जो नीचे वाला होता वो सही होता.
हाँ, मतलब आप ये कह रहे हो कि अगर कि let's say I use another equation and the equation states कि anyway it reacts with H3PO4 my corner. So it says H3PO4 and it's reacting to produce H3PO4 plus CH2. So I'll do one question. Let's say they tell us that they did a reaction in the lab, okay, and they used 30 grams of NaOH. And the energy change that they calculated for this particular reaction was, let's say, minus some hypothetical value, minus 200 kilojoules per mole, okay? So can I call this the enthalpy change of reaction? I probably cannot, because 30 grams means that mass divided by MR is 40. NaOH ki MR is that's 40. So that means the enthalpy change is for 0. How many moles of NaOH are taking part in the reaction? 0.75 moles, right? So 0.75 moles of NaOH are taking part in the reaction. And the energy in the reaction that is produced is, or the enthalpy change that is produced is minus 200 kilojoules. per mole. So it's clear that this is not the enthalpy change of reaction. Okay, if enthalpy change of reaction ke liye, the moles should have been exactly 3. Do you get the point? Okay, I did a reaction in the lab. I used is this clear?
सर मतलब जैसे ये जो इक्वेशन है ये लाइक एक तरह से एक स्टैंडर्ड इक्वेशन है इस मतलब इस रिएक्शन की.
हाँ मतलब इक्वेशन कोई भी होती है ना, that's the simplest whole number ratio. It's always the I mean,
अच्छा
ठीक है, it's always the simplest whole number
ठीक है.
ratio. अच्छा, so the point is, if I go in the lab and I do this reaction but with 30 grams of NaOH, that means the moles I'm using is 0.75 moles, and I've found out the enthalpy change. But that enthalpy change is for 0.75 moles. It is for the same reaction, but it's not for 3 moles of NaOH, which is why I wouldn't be able to call it the enthalpy change of reaction. But what I can do is, I know the ratio now. I know this, कि भाई 0.75 moles produce minus 200 kilojoules per mole, right? तो ratio लगा लो कि 3 moles कितने produce करेंगे? If you had 3 moles of NaOH, so according to this ratio, how much enthalpy change would be produced? तो आपने ratio लगाना है कि जी 0.75 जो है ना वो तो produce करे थे minus 200. So if you have 3 moles, so they're going to produce X. You crisscross and it would come out to be what? Minus 200 into 3 divided by 0.75, right? This is now equal to the enthalpy change of reaction. Because you found it for 3 moles now. Is this clear? Because बहुत सारे questions में ये करना पड़ेगा. Okay, you'll find the enthalpy change, but that enthalpy change would not be the enthalpy change of reaction, but they would be asking for the enthalpy change of reaction. तो आपने 0.75 moles के लिए निकाला था enthalpy change. So by just using ratios, you can figure out the energy change that would be evolved if 3 moles of NaOH are taking part in the reaction. Is this clear?
Yes.
ठीक है, साहब clear है. Mahad, is this clear? Sidra, Amra, is this clear? Ahmed?
Yes, sir.
So just remember, just sum this last one. Okay, if the energy change corresponds to exactly 3 moles of NaOH, then it's going to be called the enthalpy change of reaction. If it's for any random moles of NaOH, then it will not be called the enthalpy change of reaction. It would simply be called enthalpy change. So enthalpy change, जब भी question में, whenever you read the term enthalpy change of reaction or delta HR, then they mean that exactly 3 moles of NaOH. Calculate the energy change if exactly 3 moles of NaOH had taken part in the reaction. Okay. So let's continue in the next class then. Okay.
Okay, sir. Allah Hafiz.
Take care.
Okay, Allah Hafiz.
Allah Hafiz.